You walk out of the grocery store in 2026. Inflation has already gutted your wallet. The cart cost you $212 for what used to be $80 of food, and now you slide into the driver's seat of your beautiful, paid-off Japanese sedan. You press the brake pedal down, you push the engine start button, and nothing. Absolutely nothing. No crank, no click, no hum of the fuel pump priming. Instead, a tiny red padlock icon blinks at you from the dashboard cluster and across the screen in cold, sterile, factory default font. You see the 4 words that the dealership lobby has been praying you would see. Key not detected. Your stomach drops through the floorboard. Your heart starts racing. You press the button again. Nothing. You take the key fob out of your pocket. You wave it around the cabin like you're conducting an orchestra. You press every button on the thing. You even put it directly on top of the start button. And the car just sits there, mocking you, a 2,000-pound paperweight in a parking lot at 8 at night. So you do what they trained you to do. You call the tow truck. $240, by the way, just to drag your own car 3 miles to the nearest dealership. And the next morning, the service writer, with his clipboard and his fake sympathetic frown, hits you with the line they've memorized like a prayer. He says, "Sir, ma'am, your Immobilizer control module has lost its coding handshake with the body control module. We're going to need to flash the BCM, recode the Immobilizer, and cut and program 2 brand new smart keys to factory specification. The total, with diagnostic labor at $195 an hour for 5 hours, plus 2 smart keys at $400 each, plus the programming fee, comes out to $1,247. And you, standing there, already broke from groceries, already crushed by a mortgage that doubled, already drowning in 2026 inflation, you nod, because what choice do you have? You need your car, you sign the work order, you hand over $1,200 of money you do not have, and here is what makes me want to throw my coffee mug through the wall. Here is what has had me losing sleep for years. That entire repair, that entire diagnostic, that entire $1,200 invoice is a lie. It is a fraud. It is a calculated, rehearsed, corporate-trained extortion based on one single fact that you do not understand how a piece of technology that has existed since the 1940s actually works. The Immobilizer in your Japanese engineered car is not broken. It never was broken. The body control module is fine, the Immobilizer control module is fine, the keys are fine. The only thing that died, the only failure point in this entire 17,000 component vehicle is a $2 CR2032 watch battery sitting inside that little plastic fob, and the dealership knows it. They have always known it. And there is a way to start that car right now in that parking lot with the dead fob without spending a single penny that the Japanese engineers built into the vehicle from the factory as a failsafe. The dealerships, making billions off your digital panic, want you to think modern car keys are untouchable alien technology. They aren't. It's basic passive RFID technology, the exact same tech inside a hotel room key card, the exact same tech inside the tap-to-pay credit card in your wallet, the exact same tech inside the badge that opens the door at your office. But as always, I'm sharing this for educational purposes and historical observation of automotive engineering, because the goal of this channel is to make sure you understand the science that the Stealerships have buried under layers of fake diagnostic codes and inflated labor hours. Let me explain to you, slowly, exactly how this works, because once you understand the engineering, you will never be afraid of a dead key fob again, and you will never hand over $1,200 to a service writer for a problem that costs $0. There are 2 completely different radio technologies inside every modern push-to-start key fob built by Toyota, by Honda, by Nissan, by Mazda, by Subaru, by every serious Japanese automaker for the last 2 decades. The first technology is the active radio system. This is the part that needs the battery. When you walk up to your car and the doors unlock automatically because the fob is in your pocket, that is the active system at work. The fob is broadcasting a low-frequency radio signal, usually around 315 megahertz in North America or 433 megahertz in Europe and Japan, and that signal is being picked up by antennas embedded inside the door handles and the bumpers of the car. Active radio means the fob has to generate the signal itself, and to generate a signal you need power, and to have power you need a working battery. So when that little CR2032 lithium coin cell dies, that active broadcasting stops. The doors will not unlock by proximity, the trunk will not pop, the remote start will not work. And from the driver's seat, when you press the start button, the car looks around the cabin with its interior antennas, it tries to hear the active broadcast from the fob, and it hears nothing but silence. Key not detected. To the average driver and to the average crooked service writer at the Stealership, that screen is the end of the story. But it is not the end of the story. It is the beginning. Because hidden inside that exact same plastic fob, sitting right next to the dead battery, is a second, completely separate, completely independent system. This is the passive transponder. This is the passive RFID chip. And this chip does not need a battery, ever. It has never needed a battery. It will work in 1998. It will work in 2026. It will work in 2050, after a nuclear war has wiped out the power grid. The passive transponder is a tiny coil of copper wire wrapped around a microchip, the entire assembly the size of a grain of rice, and it operates on a principle that a man named Michael Faraday figured out in the year 1831 called electromagnetic induction. When you bring that little chip close to a source of an alternating magnetic field, the magnetic field induces an electrical current in the copper coil. That current powers the microchip, and the microchip then modulates the field back to transmit its unique identification code. No battery, no broadcast, just physics. The exact same physics that lets you tap a credit card on a payment terminal, the exact same physics that lets a hotel key card open your door, the exact same physics that lets a warehouse worker scan 1,000 RFID tags on pallets without ever opening a box. So here's the first piece of evidence I want you to hold in your mind. There are 3 core engineering principles that prove the dealership is lying to you, and I want to walk through all 3 of them so you never get scammed again. Principle number 1, active radio versus passive transponder. Active radio is what fails when the battery dies. Passive RFID is what was designed to never fail, because the entire point of building it into the key was to give you a failsafe for exactly this scenario. Japanese engineers, particularly at Toyota and Nissan, do not design systems that strand the driver. That is a cultural and philosophical reality of Japanese manufacturing, going back to the Toyota production system and the principle of Jidoka, which roughly translates to automation with a human touch, meaning every system must have a manual or mechanical fallback when the automated layer fails. They will not let you be stranded by a dead battery. It is built in. Principle number 2, electromagnetic induction. This is the mechanism that lets the passive chip wake up without any power source of its own. The car has to provide the field, and the chip has to be within range. And the range, this is critical. The range on a passive low-frequency RFID transponder operating at 125 kHz or 134 kHz, which is the standard frequency for automotive immobilizers, is only about 1 to 4 centimeters. You cannot just hold the fob anywhere in the cabin. It will not work. The chip must be physically touching, or within a few millimeters of the source of the magnetic field. And where is the source of the magnetic field, you ask? We will get to that in a moment. Principle number 3, the fail-safe design philosophy. Every single Japanese push-to-start vehicle made in the last 15 years has a documented, factory-specified procedure for starting the car when the key fob battery has died. It is in the owner's manual, page 300 and something, buried between a diagram of the cup holder and a warning about not putting children in the trunk. Nobody reads it. The dealerships are counting on the fact that nobody reads it. And I am telling you right now, the procedure is there, in writing, from the factory, and it is the procedure I am about to teach you. If you're tired of corporate dealerships trying to charge you $1,000 because a watch battery died, hit the like button right now, because the algorithm in 2026 has been actively suppressing this kind of repair information ever since the dealership associations started lobbying for right-to-repair restrictions. Smash that like, share this video with anyone you know who drives a push-to-start vehicle, because they will need this information eventually. Tell me in the comments if you have ever seen the key not detected message and felt your stomach drop. Tell me what the dealership quoted you. Tell me whether you paid it. We are building a database of these scams in the comments section, and I read every single one. Subscribe and hit the bell before the dealership lobby patches this out of our brains entirely, because I am not joking when I say this kind of content gets demonetized and deranked every single week. Now let's talk about the villain, the $1,200 diagnostic. Let me break it down line by line so you see the surgical precision of the scam. The service writer at the Stealership has a script. He has been trained in actual corporate training seminars to walk you through a specific emotional journey. Step 1, induce panic. Your car will not start. Maybe it is a dangerous electrical fault. Maybe it is a security breach. We need to do a full diagnostic. That is $195 right there just to plug a scan tool into your OBD2 port for 45 seconds. Step 2, escalate the problem. The diagnostic shows AP 1614 or B2799 code, which is a generic Immobilizer communication fault. Of course, it shows that code. The fob's active signal is dead. The car logged the fault. But the code does not mean the module is broken. It just means the module did not hear the fob. The service writer will not tell you that. Step 3, propose the maximum revenue solution. We need to reflash the BCM. We need to recode the Immobilizer ECU. We need to cut 2 new physical key blades. We need to program 2 new smart fobs to the vehicle. That is 5 hours of labor at $195 an hour. That is $975 in labor, plus 2 smart keys at $400 each, $800 in parts, minus a courtesy discount of $528 they pretend to give you, and you land at exactly $1,247. The number is engineered. It is calibrated. It is the maximum the average middle-class driver will pay without walking out of the dealership in protest. They have studied this. There are consulting firms that sell the math to the dealership networks. The whole thing is a designed financial trap. And the kicker, the part that should make you furious, is that after they take your $1,200, they hand you back the original fob, the one with the dead battery, and they sometimes do not even replace that $2 coin cell. They just hand it back, dead. And they hand you 2 new fobs that they programmed in 9 minutes by holding down the brake while turning the ignition cycle on and off, a procedure that anyone with an internet connection and the owner's manual can do at home for the cost of the key blanks alone, $1,200, for a battery. While inflation in 2026 is eating your savings alive, while groceries are up 40%, while your homeowner's insurance just got renewed for double what it was, the Stealerships are running this exact same dead key fob scam on, by conservative estimates, hundreds of thousands of drivers per year in North America alone. Do the math. 100,000 drivers times $1,200 is $120 million in pure extortion revenue every single year, all of it preventable by a piece of knowledge they have buried. Now let me show you the science of the bypass, the part that the dealership physically cannot suppress because it is built into the start button itself. Look at the start button on your dashboard. It is a round or rectangular button, usually with the words start or engine start on it, with a chrome or plastic ring around the perimeter. That ring, that perimeter ring, is not decorative. It is a low-frequency antenna coil. Inside the housing of the start button, wrapped around the button assembly, is a precisely tuned coil of magnet wire connected to the Immobilizer ECU. When you press the start button, even when the system reports key not detected, the Immobilizer module energizes that coil for a brief pulse, generating an alternating magnetic field at 125 kHz, radiating outward from the button. The field strength is highest right at the surface of the button and drops off exponentially with distance, which is why the active fob in your pocket cannot trigger the passive system from across the cabin. The field is short range by design. It is short range for security reasons, so that nobody can sit outside your car with a powerful transmitter and clone the chip from 20 feet away. But here is the magic. If you take the dead fob, the one with the dead battery, the one the car claims it cannot detect, and you physically press the start button with the back of the fob, with the manufacturer's logo or the keychain end of the fob, you place the passive RFID chip inside the fob directly into the strongest part of the magnetic field. The field induces current in the chip's copper coil. The chip powers up. The chip transmits its unique 64-bit or 128-bit encrypted identifier back into the coil around the start button. The Immobilizer ECU reads the identifier, matches it against the stored key database, authorizes the start sequence, and the engine fires up. It takes about half a second. There is no programming. There is no labor. There is no new key. The fob is still dead. The battery is still dead. But the car is now running because the Japanese engineers designed it to run, because they refused to let a dead $2 battery brick a $30,000 vehicle. That is what real engineering looks like, and that is what the Stealership has been hiding from you so they can keep printing $1,200 invoices. Here is the step-by-step procedure, and I want you to memorize this so you can do it in the dark, in the rain, in a panic. Step 1. Sit in the driver's seat with all the doors closed. Step 2. Press the brake pedal down and hold it down. This is critical. The brake must be depressed for the car to authorize a start sequence. Step 3. Take the dead key fob in your hand. Orient the fob so that the back side, the side with the manufacturer's logo, the Toyota or Honda or Nissan or Mazda emblem, is facing outward. The passive transponder chip is almost always embedded near the keychain ring end of the fob, on the opposite side from the active buttons, so you want that end of the fob touching the start button. Step 4, with the brake still depressed, Physically press the engine start button using the back of the dead fob itself, not your finger, the fob. Press it down like the fob is your finger. Hold it for 1 to 2 seconds. You will hear the immobilizer chime. You will see the dashboard lights cycle, and the engine will crank and start. That is it. That is the entire procedure. Some vehicles have a slight variation. On certain Toyotas, you press the button with the fob and then release. On certain Nissans, you hold the fob against the steering column where there is a backup antenna. On certain older Mazdas, there is a small symbol of a key on the dashboard indicating exactly where to hold the fob. Check your owner's manual for the exact location, but the principle is identical across every Japanese automaker. The passive RFID chip in the fob, energized by the magnetic induction coil in the start button or the steering column, transmits the security code and the car starts. Once the car is running, drive it home. Then go to any pharmacy, any hardware store, any dollar store, and buy a replacement CR2032 lithium coin cell battery for $1.99 plus tax. Pop open the back of the fob with a small flathead screwdriver or a coin, swap the dead battery for the new one, snap the fob shut, and your active radio system is back online. Total cost, $2. Total time, 90 seconds. Total savings versus the dealership, $1,245. The Stealerships are betting on your fear. They are betting on your ignorance of physics. They are betting that in 2026, with inflation eating you alive and the cost of living crushing you flat, you will be too tired and too scared to question the man with the clipboard. Do not be that person. Pass this video to every single driver you know. Memorize the procedure. Carry a spare CR2032 in your glove box. It costs $2 and it will save you $1,200. If this saved you money, or if you have a Stealership horror story of your own, drop it in the comments below, because the more we expose this fraud, the harder it gets for them to keep running it. Subscribe and hit the bell so the algorithm does not bury the next video, because we are coming for the brake job scam, the cabin air filter scam, and the transmission flush scam next, and you do not want to miss any of them. Drive safe out there, watch your wallet, and remember, the engineers already built the fail-safe. You just have to know it exists.